Good day everyone, and welcome to DepEd TV. I am your teacher Joshua. I'll be your guide in sharpening your skills and enhancing your minds in order to face the challenges here in Grade 8 Mathematics. Ready your self-learning module, your pens, and your paper with you, and let us have a wonderful day of learning. Last time, we talked about factoring polynomials with the greatest common monomial factor. Today, we will factor polynomials that we consider special products. But before that, I would like you to observe. Suppose that this square has a side that measures 3 units. What do you think is its area? The area of the square is just equal to the product of its side multiplied by itself. So what is 3 squared or 3 times 3? The area of the square is 9 square units. This illustration shows an example of a perfect square number. Perfect squares are numbers or expressions that can be expressed to the power of 2. Another example is y raised to 6, since y raised to 6 is equal to the square of y cubed. By the same logic, perfect cube numbers or expressions can be expressed to the power of 3. Example is 8, which is equal to 2 raised to the 3rd power. Now, let us try to determine the first 5 perfect squares and cube whole numbers. Before proceeding with factoring, let us recall how to multiply polynomials. What is the product of the sum and difference of 2 terms? The quantity a plus b times the quantity a minus b. Remember that we can use the FOIL method to multiply our polynomials. We distribute each term to the other group. The first term will be the product of the first terms of each binomial. A times a, which is a squared. Next is we multiply the outer terms. Positive a times negative b is negative ab. Then the inner terms, positive b times positive a is positive ab. The last term is the product of positive b times negative b, which is negative b squared. We can simplify the polynomial by combining like terms, which will give us a negative ab plus ab equal to 0. Hence, we are left with a squared minus b squared. This is a special product that we call the difference of 2 squares. This polynomial is a special product because there is a pattern that is so unique to its form. Multiplying polynomials is like driving a car forward. You are given a starting point and you need to find the product at the last destination. While factoring is the reverse process of multiplying polynomials. We will drive backwards as we are given with the product and we are asked to find its factors. With the previous example, we can say that the factors of a difference of 2 squares, a squared minus b squared, is the product of the sum and the difference of the positive square roots of each term, the quantity of a plus b times the quantity of a minus b. Look at the square wooden panel. The length of each side measures 9 inches. What is the area of the wooden panel? The area is 81 square inches. Now, I want to make a picture frame using this square panel by cutting a square hole inside whose shape and size is equal to the photograph to be placed in. Since I'm not yet decided on the size of the photograph, let us just say its side measures p inches. What will be the area of the picture frame in factored form? We know that a square hole is to be cut in the square wooden panel. So we will subtract the area of the photograph from the area of the wooden panel. It is stated that the side of the panel measures 9 inches. So the area of that square panel is 81 square inches. Then, we will subtract the area of the photo from the area of the wooden panel. The area is p squared. What kind of polynomial is this? This is a difference of two squares. The polynomial can be expressed as the square of 9 minus the square of p. Hence, the factored form of the area 81 minus p squared is equal to the quantity of 9 plus p times the quantity 9 minus p. But do not forget the unit, square inches. How about this one? Write 16a raised to 6 minus 25b squared in factored form. We start with checking if each term is a perfect square. 16a raised to 6 is equal to the square of a cubed, while 25b squared is equal to the square of 5b. The polynomial is a difference of two squares, since both terms are perfect squares. And the operation is subtraction. Hence, 16a raised to 6 minus 25b squared is equal to the quantity of 4a cubed plus 5b times the quantity of 4a cubed minus 5b. There are some cases of polynomials that do not seem to be a difference of two squares, since the terms are not perfect squares. But remember, there are other ways to factor your polynomial. Consider this example. Factor 3w squared minus 48 completely. Are the terms of 3w squared minus 48 perfect squares? No, they are not. What else can we do to factor the polynomial? Note that both terms have a common factor of 3. Hence, the binomial can be factored using a combination of the greatest common monomial factor and the sum and difference of two terms. Since we have identified that the greatest common factor of 3w squared minus 48 is 3, we can divide the polynomial by the common factor, so we can express it as 3 multiplied by the quantity w squared minus 16. Then observe that the polynomial factor is a difference of two squares. We can further show that the expression 3 times the quantity of the square of w minus the square of 4. Can you give me the final factored form? We can write the polynomial 3 times the quantity of w plus 4 times the quantity of w minus 4. Do you know what this is? This is a Rubik's Cube invented in 1974 by Erno Rubik. There are many variations of this puzzle, and there are also infinite number of ways to solve this. The world record in the fastest solve of a Rubik's Cube is 4.22 seconds by Felix Zemdega. Just like this Rubik's Cube with different sides or faces, the difference of two squares is just one of the several special products. The next two involve cubes. The difference of two cubes, a cubed minus b cubed, and the sum of two cubes, a cubed plus b cubed. But first, let us show how to get this special product. Multiply the quantity of a minus b times the quantity of a squared plus ab plus b squared. We can first multiply a to each term of the trinomial. A times a squared is a cubed. A times ab is positive a squared b. And a times b squared is positive ab squared. Next is to multiply negative b to each term of the trinomial. Do not forget the signs in multiplying. we will have negative b times a squared is negative a squared b. Then, negative b times ab is negative ab squared. And negative b times positive b squared is negative b cubed. Combining like terms, we will remove zero pairs, positive and negative a squared b and ab squared. Thus, we are left with a cubed minus b cubed. We showed that the binomial a minus b multiplied with the trinomial a squared plus ab plus b squared is equal to the difference of two cubes. Since they are equal, we can also say that the reverse is the same, meaning that the factored form of the difference of two cubes is given by this pattern. The pattern is also similar in factoring the sum of two cubes, a cubed plus b cubed. What do you notice? Where do they differ? The sign or operation in the binomial factor and the first operation in the trinomial factors are different. They both depend on the operation used in the polynomial. There is a special trick for us to remember the signs used in this sum or difference of two cubes. You can use the mnemonic SOP, meaning same, opposite, positive. The binomial factor has the same sign or operation with the given. The second sign or the first operation in the trinomial factor is opposite of the binomial. The last sign is always positive, regardless of the given. Look at these boxes. They are both cubes. I would like to put the smaller box inside the bigger box. And to keep it safe, I will insert some styrofoam chips that will fill the empty space in the bigger box. How much styrofoam chips is needed to fill the space and completely secure the smaller box? The bigger box has a width of 5 inches, but I do not know the size of the smaller box. So let us represent it with x. Since we are asked about the amount of space to be filled, we are talking about the volume. What is the formula for the volume of a cube? The volume of the cube is given by the equation V for volume equal to s cubed, where s is the length of its side or edge. So what are the volumes of the bigger box and the smaller box? The volume of the bigger box is equal to the cube of 5, which is 125 cubic inches, while the volume of the smaller box is x cubed, since we didn't know the exact measure of this side. Now, let us place the smaller box inside the bigger box. What happened to the volume inside the bigger box? It got smaller. So the amount of space to be filled by styrofoam chips is just the volume of the bigger box minus the volume of the smaller box. Substituting the values that we have, the volume of the empty space is equal to 125 minus x cubed cubic inches. We can also write this in factored form since it is a difference of two cubes. Again, we can express 125 as the cube of 5 minus x cubed. We write the binomial factor using the expressions we acquired, 5 and x. Remember that the first sign is the same with the given. So we will have 5 minus x. Then, the first term of the trinomial factor is the square of 5, which is 25. The next operation is opposite the binomial. What is opposite of minus? It is plus. Then the middle term is the product of 5 and x. 5 times x is just 5x. The last sign is always positive, or a plus sign. So finally, the last term is the square of x, and it is x squared. The factored form of the amount of space the styrofoam chips need to fill is the quantity 5 minus x times the quantity 25 plus 5x plus x squared. How about this example? Factor 40k cubed plus 5. If you notice, the operation involved is addition. But the terms are not perfect cubed expressions. So what else can we do? Observe that both terms are divisible by 5. Hence, a greatest common monomial factor exists. We can write the polynomial as 5 times the quantity 8k cubed plus 1. Then, we proceed to factoring the sum of two cubes. 8k cubed is the cube of the expression 2k, while 1 is equal to the cube of 1. Next, what is the binomial factor? It is 2k plus 1, since this is a sum of two cubes. Then the first term of the trinomial is the square of 2k. What is it? It is 4k squared. The next operation must be minus because we need the opposite of the previous one. After that, we multiply the terms of the binomial. 2k times 1 is 2k. The final sign is always a positive sign. So lastly, the third term of the trinomial is 1 squared, and the answer to that is 1. So we can say that 40k cubed plus 1 is equal to 5 times the quantity 2k plus 1 times the quantity of 4k squared minus 2k plus 1. And there you have it. That's our lesson for today. Now, let us have a recap. Some polynomials are called special products because they have a certain pattern that we can use in factoring them. The difference of two squares, a squared minus b squared, is equal to the product of the sum and difference of the roots of each term, a plus b and a minus b. The sum and the difference of two cubes are the product of a binomial and the trinomial factor whose signs depend in the given polynomial. Remember the mnemonic SOP. Same, opposite, positive, when writing the signs or operations in factoring these special products. And now that we are near the end of your lesson, prepare your pens and your paper because it is important to evaluate what you have learned. I will give you 5 seconds to answer each problem. Choose the letter that contains the correct factors of the given polynomial. Number 1, factor d squared minus 25. Is it A, the quantity d plus 5 times the quantity d minus 5? Letter B, the quantity d plus 25 times the quantity d minus 25? Or is it C, d plus 5 times the quantity d squared minus 5d plus 25? Or D, the quantity d minus 5 times the quantity d squared plus 5d plus 25? The correct answer is A, the quantity d plus 5 times the quantity d minus 5. Next number, factor 25e squared minus 16. Is it A, e plus 4 times e minus 4? B, the product of 5e plus 4 and 5e minus 4? C, the quantity of the sum 5e plus 4 times the trinomial 25e squared minus 20e plus 16? Or D, 5e minus 4 times the trinomial 25e squared plus 20d plus 16. The correct answer is B, 5e plus 4 multiplied by the quantity 5e minus 4. Number 3, factor 20c squared minus 45d squared. The choices are A, the quantity 2c plus 3d times the quantity 2c minus 3d. B, the quantity 4c plus 9d times the quantity 4c minus 9d. Letter C, 5 times the quantity of 2c plus 3d times 2c minus 3d. Or D, 5 times the quantity of 4c plus 9d times the quantity 4c minus 9d. Correct answer is letter C, 5 times the product of the binomials 2c plus 3d and 2c minus 3d. How was the activity? Did you find it difficult? Just keep on practicing on the examples and assessment found on your self-learning modules. Remember that in mathematics, practice makes you better. As an additional exercise and practice at home, try answering the activity on your self-learning module about factoring special products, the difference of two squares, and the sum or difference of two cubes. I hope that you have learned a lot in our episode today. Note that there are many ways to solve a problem, and you must focus on the steps and patterns or the process that you have observed in factoring these polynomials. With practice and determination, I believe that you can ace any lesson in mathematics. For our next episode, we will be factoring polynomials with 3 terms, or what we call trinomials. Remember, math is not only about numbers and operations. It is an exercise of our minds for us to be critical, logical, and responsible thinkers. Again, this is Teacher Joshua reminding you to keep safe, have a nice day, and see you again next time.